Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 4.12 from the C Programming Language textbook by Kernighan and Ritchie. Now, exercise 4.12 says to adapt the ideas of print D to write a recursive version of itoa. That is, convert an integer into a string by calling a recursive routine. So let us just remind ourselves what print D was doing. It had something like this, and then that, and then I think it was like something like this. Might have used printf, I can't remember, but let's just see what this does. So this first if n divided by 10, all that is doing is it's checking if n has more than one digit. That's really it. And then we call it recursively on the same number n with all its digit except the last digit. And then after, we can just print the last digit. So you can see how we're breaking up this problem. A lot of recursion just comes down to breaking up the problem into smaller subproblems of the same type. Okay, so let's have this same kind of structure with itoa. So if my number has more than one digit, then I can just call itoa on the number with all the digits except the last one. If I can store all of those in S, then I can put the final digit, I can set the final digit of S. So as an example, if I have 1, 2, 3, well then I can just call itoa on 12, and then after that I can set the respective value of, let's say, final digit index as to that. Now, you could already see, I mean, what on earth is that? Well, that's a problem. How do I know what index my final number should be? If I have a 3-digit number, then it should be 2. But if I have a 10-digit number, then the final index will be 9. If I have a 15-digit number, it'll be 14. The problem is I don't know how big this number is ahead of time. Now, we could work it out. We could write a helper function to help us work out how many digits a number has, and it wouldn't be too difficult. But then we start getting into problems because if we find out how many digits a number is and we find what index we should put, then what if we have a negative number? Everything's going to be shifted down by 1 because the first index should be a negative sign. So you're going to have 2 cases and it's just going to get a little messy. You could do it, but I think there's a better way. What I would do is I would use a static internal variable, an integer I that will be an index into S, and this index will be shared across all function calls, and all these function calls will respectively increment it and change its value so that the next function call can use it properly. So let's think about the base case. Well, if n has more than one digit, we go into the recursive case. What about the base case? Well, when is that going to be the case? It will be if n is a single digit. If n is a single digit, then I know that I is going to have to be I. I is going to be 0. So I can now set i's value. I know if it's a single digit, no matter what, I is going to start at 0. Then I can check. If n is less than 0, s of I should be a negative sign. And I'm going to flip the sign of n so that this will work properly. I could use absolute value, I guess, but actually no, it will make stuff a little messy. Else, oh, and here's something I almost forgot. After I set s of I to be the negative sign, I should increment I. And I could do this here instead. Otherwise, s of I should equal And I should also increment I. Okay. Now what? Let's look at a simpler example. Let's say itoa on 12. itoa on 12. This will get called. So then we will call it recursively on 1. And then we will have, if we call itoa on this, the value of I will be set to 0. And then we will jump back into this function call and it will go to this line. So now that it's on this line, because this function call incremented I here, the base case set I and incremented it, now here we can use the value of I like that. And we should also increment it for the next call. But we should set the final value to be the null terminator. And what happens is this. Let me make some more white space so it's a bit clearer. What happens is this. Actually, we're going to do that twice, aren't we? Yeah. Actually, I shouldn't even have an else. Because then I'm going to do it twice. Yeah. Okay. That's much better. So if n is a single digit, we'll just set I to be the first index. And then we'll do that. We will get that digit stored in there, increment it, and then set the index after it to null. Now, if there's no more digits after this, we are done. But if there are, it's going to bubble back up into the function that called it, and the null terminator will be overridden by the next function call, because the value of I is shared across all function calls. I really think it'd be better if you run through this program and just have like a diagram of all the function calls and all the values in between to fully understand it, but I think this is okay now. Let's have a go. Oh, what happened there? Oh, I should make this absolute value, because the sign because this n is only going to be flipped for one of the function calls. I don't even think I need this. Let me include the header. Yes. Let's just see that one more time. Yep. Yeah, so I don't even need to flip the sign. Flip before I had this, but that was stupid because that's only going to be for one of the function calls. All the other function calls n's are still going to be negative, so there's no point. Instead, we will just use the absolute value. Okay, like I said, I think it's best to experiment with that program because recursion can get a little messy. It's not the easiest concept to explain. But other than that, that is all for this video. Thank you all for watching, and I'll see you all in the next one. Bye-bye.